Hey everybody, thanks for clicking on this video. Today we're going to be looking at partial fraction decomposition with repeated linear factors. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos we have coming out from the channel. So let's get started. Now in our previous video, we talked about how to do partial fraction decomposition when the factors are all different. But what's new in this video is dealing with partial fraction decomposition when you have a factor like this, x minus 1, which is squared. So let's set this up. We have x squared all over the quantity x plus 1 times x minus 1 squared. And that's going to equal a number a over x plus 1 plus b over. Now when we have a term with an exponent, we start with no exponent. So that's going to be just x minus 1. And then we raise it to the next. So this is going to be x minus 1 quantity squared. Now people will often worry about, well, shouldn't this have a higher degree? No. When you repeat it, you just copy whatever this is. So this is a number, so this will be a number, just different. Now, if this were cubed, we would then write x minus 1 cubed. But we don't have that. It's just squared. So now we're going to multiply by this denominator, x plus 1 times x minus 1 quantity squared. So when we do that, we have x squared over on the left. We have a times, now the x plus 1 will cancel, leaving quantity x minus 1 squared. For b, one of the x minus 1's will cancel, leaving an x plus 1 and an x minus 1. And then for c, both the x minus 1's cancel out, leaving just x plus 1. Now we need to expand these three out. So we're going to have a, and x minus 1 squared is x squared minus 2x plus 1. X plus 1 times x minus 1 is going to be x squared minus 1. And then what we have to do is now we have to distribute in the a, the b, and the c. So we have ax squared minus 2ax plus a plus bx squared minus b plus cx plus c. Now, what we have over here on the left-hand side is an x squared. Now that can only come from these terms that have an x squared. They can't come from terms that have an x or no x. So we have 1x squared equals ax squared plus bx squared. And in reality, all we care about are the coefficients. So we can just drop the x squared and just have 1 equals a plus b. Now, what do we do about the rest? Well, let's look at these terms. These terms have an x attached to them. There is no x over here, though, and that's because it has a coefficient of 0. So we take negative 2a, now again, we don't need the x, plus c. And then finally, we have this term, and this term. And these are constants, but since there's no constants, that's going to equal 0 also. So that's going to be a minus b plus c. So these are the three equations we need to solve. Now we're going to use a matrix on our calculator to solve this. So I'm going to need a 3 by 3 matrix first, and I need the coefficients. So a is 1, b is 1, there is no c, so we leave that as 0. For the second equation, we have negative 2 for a, nothing for b, and 1 for c. And then for this third equation, we have 1 for a, negative 1 for b, and then positive 1 for c. So there's our coefficient matrix. We're going to type the inverse of that. And then next, we're going to need a 3 by 1. And now I'm going to need these numbers here. So 1, 0, and 0. So we get 0.25, we get 0.75, and we get 0.5. So that's what a, b, and c equal. So a equals 1/4, b equals 3/4, and c equals 1/2. So the way we would write this is x squared over x plus 1 times x minus 1 squared is going to break down into 1 over 4 times x plus 1. There's our 1/4 coefficient. For b, it's going to be 3 over 4 times x minus 1. And then for c, it's going to be 1 over 2 times x minus 1 squared. So that is how this fraction breaks down. Let's look at another one. Now with this one, we first have to factor it in order to write the decomposition. So it's going to be x plus 2 all over, and we can factor an x out. So we're left with x squared minus 2x plus 1. And so this will factor into x plus 1 times x plus 1, which is just x plus 1 quantity squared. So when we write down this partial fraction decomposition, we've got x, so we're going to have a over x. And then we have x plus 1 quantity squared. So we're going to have b over x plus 1, and then c over x plus 1 quantity squared. So what we'll do is now we'll multiply everything by this denominator, x times x plus 1 quantity squared. So we're left with x plus 2, and that equals, we're going to have a times x plus 1 quantity squared. We're going to have b. Now one of the x plus 1's cancel, but it's going to leave an x and an x plus 1. And finally, x plus 1 squared cancels, leaving just x. So now we'll multiply these out. So this is going to be x squared plus 2x plus 1 plus b times x squared plus x plus cx. And now when we distribute this, we get ax squared plus 2ax plus a plus bx squared plus bx plus cx. Now again, all of this equals x plus 2. So we've got the x term, and so that's going to equal anything with an x attached to it. So that means this x has a coefficient of 1. And so that's going to equal 2a plus b. Next, we've got plus 2. And let's see, that has an x squared, that has no x, that has an x squared, that has an x. So 2 is going to equal a. Well, that's handy for us, so we don't have to work very much to solve this. So then finally, we've got, whoops, I forgot something. That c has an x, so that should be going up there. My mistake. And then finally, we have ax squared plus bx squared, but there is no x squared. So that means those two coefficients, a and b, are going to have to add to 0. All right. Now since we already know what a is, a plus b have to add up to 0. So that means b has to equal -2. So all we have to do now is work out what is c. So if a is 2 and b is -2 plus c, that means we have 1 equals 4 minus 2 plus c, so 1 equals 2 plus c. So when we subtract 2, we get -1 equal to c. So when we write out our partial fraction decomposition, we originally had x plus 2 over x cubed minus 2x squared plus x. And so that's going to be a is 2, and that was over x. Then we had b, that was -2. So instead of plus, we're just going to say minus 2 over x plus 1. And then c is -1, so -1 over quantity x plus 1 squared. So that is how this will break down. Now in the next one, with this one, here we have one factor, but it is to the 3rd power. So when we write this out, x squared minus 2x plus 1 all over quantity x minus 2 cubed, we're going to start with x minus 2. And then we're going to raise it to x minus 2 squared. And then we're going to have x minus 2 cubed. So we start with no exponent, and then we keep raising it until we get whatever we had to start with. So we'll multiply this by x minus 2 cubed. So when we do that, this cancels away, so we're left with x squared minus 2x plus 1. One of the x squareds will cancel, leaving 2 of them. So x minus 2 squared. Here 2 of them cancel, leaving 1 of them. X minus 2 plus c. So let's expand this out. X minus 2 quantity cubed is x squared minus 4x plus 4 plus b times x minus 2 plus c. So then we distribute the a and distribute the b. Ax squared minus 4ax plus 4a plus bx minus 2b plus c. Now again, all of this equals x squared minus 2x plus 1. So first, x squared. Well, there's only one term with x squared, so that means 1 has to equal a. Good start. That means we know what that is. So then anything with an x, so this coefficient, negative 2, is going to equal negative 4a plus b. And then finally, this coefficient of 1 can only equal this, this, and this. So we have 1 equals 4a minus 2b plus c. Okay, but we know that a equals 1, so we can plug that into this equation. So negative 2 equals negative 4 plus b. So when we add 4, that means we get 2 equals b. So now, when we plug in 1 in for a, we get 4. When we plug in 2 in for b, we get minus 4 plus c. So those cancel out, so we have just 1 for c. All right, so that means, let's write out our partial fraction decomposition all over x minus 2 cubed. So a was 1 over x minus 2. Then b was 2 over x minus 2 quantity squared. And then c was 1 all over x minus 2 quantity cubed. Now on our last problem, here we have 2 multiples going at the same time. We have x, which is squared, and x minus 1, which is cubed. So we got a lot going on here. So when we write this out, first I'll start with x. So we have a over x, and then it's going to become b over x squared. Now that's the highest power on x squared, but then we go to x minus 1, and then we have x minus 1 quantity squared, and then we have x minus 1 quantity cubed. So first step, we're going to multiply by x squared times x minus 1 cubed. So that's going to leave x cubed minus 8 over here. One of the x's will cancel, so we're going to have one of the x's and all 3 of the x minus 1 factors. Here, both of the x squareds will cancel, so we have b times x minus 1 cubed. Here, we have both x squareds, we have both x's, and we have 2x minus 1 squared. Here, we're going to have x squared times x minus 1. And then here, all 3 x minus 1's cancel, so all we're left with is x squared. Okay. Now let's do this off to the side just for reference. We're going to need x minus 1 squared. Now if we expand that out, that's going to be x squared minus 2x plus 1. But x minus 1 cubed, that's the same as x minus 1 times x minus 1 squared. So that's going to be x minus 1 times x squared minus 2x plus 1. So if I multiply everything in this by x, I get x cubed minus 2x squared plus x. Then we multiply everything by negative 1, minus x squared plus 2x minus 1. So altogether, this is going to equal x cubed minus 3x squared plus 3x minus 1. All right. So when we expand this out right here, we're going to have a, and it's x times this. Now we already found that x minus 1 cubed is this, but I need to multiply by another x. So it's going to be x to the 4th minus 3x cubed plus 3x squared minus x. Now for b, this is just x minus 1 cubed. So that's just going to be what we wrote here. X cubed minus 3x squared plus 3x minus 1. Now this cx is x squared times x minus 1 squared. So I have to take this and multiply by x squared. So I have x to the 4th minus 2x cubed plus x squared. All right, and almost out of room, so we'll start a new line. Now d is going to be x squared times all that. So that is going to be x cubed minus x squared, and then finally plus ex squared. So now we have to distribute in the a, the b, the c, d, and e. So ax to the 4th minus 3ax cubed plus 3ax squared minus ax plus bx cubed minus 3bx squared plus 3bx minus b. Then we distribute the c plus cx to the 4th minus 2cx cubed plus cx squared. And then for d, plus dx cubed minus dx squared plus, and then the final term ex squared. Now what is all of this equal to? Well, it's all equal to what we started with, x cubed plus minus 8. That was our original numerator. All right, so where are the x cubed terms? Well, here's one, there's one, there's one, and there's one. So our coefficient is going to be 1 equals negative 3a plus b minus 2c plus d. Now what about this 8? Where's that? Well, that's any term that doesn't have an x attached to it. All right, and by the looks of things, the only term that doesn't have an x attached is b. So negative 8 equals negative b. But what about the rest? Well, we have 5 different quantities, which means we're going to need 5 different equations in order to solve this. So let's see, where are the terms that have x to the 4th? Right here, with a and c. But there is no x to the 4th. So 0 is going to equal a plus c. Now, what about the terms that have x squared? There is no x squared, but we need to take them into account. So we have x squared, x squared, x squared, x squared, and x squared. So that's going to be 3a minus 3b plus c minus d plus e. Now what about the terms with x's in them? So there's an x and there's an x. Again, there's no x, so it's equal to 0. So we have negative a minus, plus 3bx. So I'm referencing this term and I'm referencing that term. Now, with 5 equations and 5 variables, we are definitely using a calculator for this. All right, so I'm going to need a 5 by 5. Okay. And so I need all of these coefficients. So -3 for A. Whoops. No, not done. So it shouldn't have pressed enter. All right. So for B, that should be a 1. For C should be -2. For D should be 1. And for E, we'll leave that as 0. Now for the next equation, the only coefficient is -1 for B. Now we know B is -8, but the others may take a little extra work. And then we have 1 for A and 1 for C. And then we have 3 for A, -3 for B, 1 for C, -1 for D, 1 for E. And then on this final equation, we have -1 for A, and we have 3n for B. All right, and so that's inverse. And now I'm going to need a 5 by 1. And so now I just include these numbers. So we have 1, -8, and the rest are zeros. So there are our answers. Those are the values for A, B, C, D, and E. So x cubed minus 8 all over x squared times x minus 1 cubed. Now A was 24 over x. B was 8 over x squared. C, -24 over x minus 1. D was 17 over x minus 1 squared. And then E was -7 over x minus 1 cubed. And there is our partial fraction decomposition. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.